Welcome all. In today's presentation, we are going to see about introduction of prestressed concrete structures. Prestressed concrete. Prestressed concrete is basically a concrete in which the internal stresses of a suitable magnitude are introduced so that the stresses resulting from the external loads are counteracted to the desired degree. Principle: using the high tensile strength steel, producing permanent pre-compression in the area subjected to tension. Methods: there are two main methods, pre-tensioning and post-tensioning. Pre-tensioning is a method of placing of concrete around the reinforcing tendons that have been stressed to the desired degree. Post-tensioning: reinforcing tendons are stretched by the jacks, keeping them inserted in the voids left freehand during the curing of concrete. History of prestressed concrete. The concept of prestressed concrete was developed in the year 1888 by P.H. Jackson. Then it was further developed by Eugene. The first book of design in prestressed concrete was done by Steve Magnell. Why prestressed concrete? Why we are preferring the prestressed concrete? What are the reasons? The reasons are: the concrete components remain uncracked. There will be the reduction of steel corrosion. The increased durability of structures. The structures are good for pressure vessels. High span to depth ratio. More economical. Forms. Main reinforcement steel used in prestressed concrete are wires, stands, tendon, cable, and bars. Wires. Pre-stressing wire is a single unit made of steel strands. Two or more several wires are wound together to form a pre-stressing strand. Tendon. A group of strands are wound together to form a pre-stressing tendon. Cable. A group of tendons form a pre-stressing cable. Bars. A tendon can be made up of a single steel bar. These are the main steel elements used in the prestressed concrete. See the images. The difference between the reinforced and the prestressed concrete. Reinforced concrete when unloaded position and loaded position. Prestressed concrete in unloaded position and loaded position. See the image. Main types of internal prestressed concrete. There are three main types: pre-tensioned concrete, bonded post-tensioned concrete, unbonded post-tensioned concrete. Pre-tensioned concrete. Pre-stressing steel is a tension stressed prior to the placement of the concrete and unloaded after the concrete has hardened to the required strength. Bonded post-tensioned concrete. Unstressed pre-stressing steel is placed within the concrete and then tension stressed after the concrete has hardened to the required strength. Unbonded post-tensioned concrete differs from the bonded post-tensioning by providing the pre-stressing steel permanent freedom of movement. There is an image for bonded post-tensioning and unbonded post-tensioning. Prestressed pre-tensioned concrete. Prestressed pre-tensioned concrete is when the steel reinforcement is stressed prior to the concrete being placed around the steel. Pre-tensioned concrete is cast around the already tensioned tendons. This method produces a good bond between the tendon and concrete, which both protects the tendon from the corrosion and allows to direct transfer of tension. Thus, the most pre-tensioned concrete elements are prefabricated in a factory and must transported to the construction site. Concretes with pre-tension. Usually it uses a mold which is able to resist the forces within the tendons which are more expensive than the regular mold. Concrete sample should be taken for every new mix so that the strength obtained may be determined before cutting the tendons, releasing the stresses onto the concrete. Advantages of pre-tension. The main advantage of pre-tension is the bond between the steel and concrete is highly effective. It is the main advantage. Post-tensioning. From the word itself, we can understand that the bars are tensioned after the concrete is hardened. Post-tensioning is a method of reinforcing the concrete with the high-strength steel strands called tendons. Post-tensioning allows construction that would otherwise be impossible due to either site constraints or architectural requirements. It requires a specialized knowledge and experts to fabricate, assemble, and install. After adequate curing of concrete, reinforcing tendons are tensioned by jacks and grouts are filled with the appropriate mix. Applications of post-tensioning are structural members, beams, bridge deck panels, roof slabs, concrete slots, etc. Benefits. The concrete is very strong in compression but weak in tension. This deflection will cause the bottom of the beam to elongate slightly and cause cracking. Steel reinforcing bars are typically embedded in the concrete as the tensile reinforcement to limit the crack widths. These are the main benefits of bonded post-tensioned concrete. The image shows the bonded tendon system. Wire strands are inside, around the cement grout, and surrounded by the metal duct. Bonded post-tensioned concrete. It is the process showing how the bonded post-tensioning concrete are made. The concrete is casted around the curved duct to allow the tendon to be inserted. After the concrete has hardened, the tendons are pulled in tension and then wedged. The duct is then injected with the grout. Advantages. Tendons are less likely to de-stress in accidents. Tendons can be easily waved, allowing more efficient design. Higher ultimate strength due to bond generated between the strand and the concrete. No issues with the maintaining the anchor. Unbonded post-tensioned concrete. The image shows the unbonded tendon. The seven wire strands surrounded with the corrosive coating. See the image. Unbonded post-tension. In post-tensioning, the steel in the concrete is stretched after the curing process. Unlike bonded tendons, unbonded provides the tendons freedom of movement by coating each tendon with a grease and covering with a plastic sheathing. Tension on the concrete is achieved by the cables acting against the steel anchors that are buried in the perimeters of the concrete. Advantages of post-tensioned unbonded concrete. Post-stress grouting is eliminated. Ability to de-stress the tendons. It's economical, it's replaceable, simple stressing equipment is needed. See the image. There is a different types of anchors, encapsulated anchors, standard anchors, and wedges. See the images. There is a lock rings, grease cap. These are the detailed images. Advantages. Post-tensioning, which is a form of the pre-stressing, has several advantages. It reduces or eliminates the shrinkage cracking, therefore no joints or few joints is needed. It allows the slabs and other structural members to be thinner, It allows us to build the slabs on the expansive or the soft soils. It allows us to design longer spans in the elevated members like floors or beams. Material savings, quicker construction, increased performance, reduced lifetime cost. These are the main advantages of post-tensioning. Difference between the post-tensioning and pre-tensioning. In post-tensioning, it can be performed at the project site as well as the precast yard. In pre-tensioning, it is difficult to perform at the site, only done in a precast yards. In post-tensioning, corrosion of the steel is less as compared to the pre-tensioning. In pre-tensioning, corrosion of the steel will higher. In post-tensioning, there is a less loss of pre-stress due to concrete shrinkage. In pre-tensioning, there is a greater loss of pre-stress due to the shrinkage of concrete. In post-tensioning, there is more flexibility in design. The pre-stressing tendons can be configured to almost any shape. But in pre-tensioning, tendons can only be straight or circular. In post-tensioning, they are more prone to anchorage failure. But in pre-tensioning, the compressive forces are transferred over the certain length of the bond. They are less prone to anchorage failure. So generalized post-tensioning is usually better than pre-tensioning. However, this may not always be in the case. Manufacturers of pre-stressed concrete in India. IHP, Indian Hume Pipes, introduced the prestressed concrete monoblock sleepers for railways in the year 1970. Then prestressed concrete pipe and prestressed concrete cylinder pipe are introduced. These are the main introduction about the prestressed concrete structures. Next presentation, we will see about the syllabus topic wise. Thank you.